Have you ever pressed your hand against a wall and wondered what you're actually touching? The physicists at CERN will tell you quietly, you're not touching it. The electrons in your skin are repelling the electrons in the wall. Contact is an illusion. And that's the least unsettling thing about what they've found. Right now, the equations governing every atom in your body are known to be wrong, officially, publicly, confirmed by the people who wrote them. CERN has spent 15 years searching for what lies beyond those equations. The silence they found is the most important result in the history of physics. Subscribe if this matters to you. The crack goes deeper than you think. There is a set of equations governing your body right now. Every atom in your chest, every particle threading through your neurons, every force holding your cells together, all of it is running on a framework physicists call the Standard Model. It is the most precisely tested theory in the history of science. It has never once failed a controlled experiment. Physicists use it to predict the behavior of subatomic particles to 11 decimal places, a precision equivalent to measuring the distance from New York to Los Angeles and being wrong by the width of a single human hair. And its own authors have known for decades that it is broken. Sit with that for a moment. The theory running your body has a hole in it. That sentence is not a metaphor, not a dramatic flourish for a YouTube video. It is the official, published position of every major physics institution on Earth. The Standard Model is explicitly, demonstrably, provably incomplete. Physicists at CERN, at Fermilab, at MIT, at every institution that matters, all say the same thing in print. The Standard Model works, and the Standard Model is wrong. What does that mean for you? Sitting there in your room, breathing air whose molecules are obeying equations that the people who wrote those equations know are insufficient. Here is the chain of logic. The Standard Model describes every particle we have ever directly detected. It predicts their behavior with extraordinary precision. In every lab test ever conducted, it is right. But there are things it cannot account for at all. Things that are not edge cases or minor corrections. Things like 95% of the energy and matter content of the universe. Things like why you exist instead of nothing. The Standard Model, at its core, is a map of a city drawn by someone who has only ever seen one neighborhood. The map is perfect. The neighborhood is real. But step outside it, and the map goes blank. Physicists have been living with this since at least the 1970s. When the theory was first fully assembled, the Standard Model was celebrated as a triumph, a unified description of 3 of the 4 fundamental forces, a complete catalogue of the particles that make up matter. And in the same breath, in the same papers, physicists noted what the model left out: gravity, dark matter, the origin of mass in the early universe, the reason matter exists at all. These were not small omissions. They were the most important questions physics had ever tried to answer, and the theory that was winning every Nobel Prize in sight had nothing to say about any of them. So why keep using it? Because it works. Because the part of the universe it does describe, it describes with a precision that nothing else comes close to matching. You use a map of one neighborhood when you are in that neighborhood. The problem is, for the last half-century, we have been discovering that the universe is vastly larger than the neighborhood, and the map still ends at the same border it always did. Right now, the atoms in your hand are obeying those equations. Every electron in your fingertips, every quark vibrating inside every proton in every cell of your body, is following rules that physicists know are a fragment of something larger. You are a machine running on incomplete instructions. The instructions work every single time, in every test ever run. And somehow, that makes the incompleteness more disturbing, not less. If the theory were wrong in ways you could measure, you could fix it. But the Standard Model is right everywhere you look, and wrong about everything beyond the edge of where you have looked. That border is not theoretical. It is showing up in real experiments, in real data, at real colliders. CERN is finding the edge of the map. What lies beyond it is something no equation currently written can describe. So here is the question that should unsettle you as you sit there. The theory governing your body is, admittedly, officially, certifiably, incomplete, which means the forces holding you together are obeying rules that no one fully understands. What exactly are those rules? And what happens if we find out the answer is stranger than anyone is prepared for? Before we go any further, you need to confront what the laws of physics actually say you are made of, because the answer is going to change how the rest of this lands. You have probably heard that atoms are mostly empty space. That is technically true, but it understates the situation by such a large margin that saying it that way is almost a lie. Your body is not mostly empty space the way a house is mostly empty space, with solid walls and floors and the air in between. Your body is empty space the way the universe between galaxies is empty space. The math is this: if you removed all the empty space from every atom in every human being on Earth, all 7.9 billion of us compressed down to pure matter with no gaps, the result would fit inside a sugar cube. The fraction of you that is not empty space is 99.9999999999996% void. The remaining fraction, the part that is not void, is smaller than anything your intuition can actually hold on to. But here is where it gets more disturbing. That remaining fraction, that tiny sliver of mass that is not emptiness, is mostly not what you think it is either. You are made of atoms. Atoms are made of protons, neutrons, and electrons. Protons and neutrons are made of quarks. You might assume that the mass of a proton comes from the mass of the quarks inside it. That assumption is wrong by a factor so large it changes the entire picture. The 3 quarks inside a proton together account for roughly 2% of the proton's total mass. 2%. The other 98% is not matter in any conventional sense. It is the kinetic energy of those quarks moving, the energy of the gluon fields binding the quarks together, the constant churning motion of particles that cannot hold still because quantum mechanics forbids them from holding still. Your mass, the number your scale reads when you step on it, the weight of your bones and your blood and your brain, is almost entirely the energy of motion. You are not a solid object. You are a pattern of forces in motion, and the pattern happens to be stable enough that it reads as a body. Pause on that. 98% of your body's mass is not the mass of any particle. It is the energy of movement inside particles that are themselves nearly massless. The physicist Frank Wilczek, who won the Nobel Prize for his work on the theory of the strong force, described this by saying that most of what we call matter is really a kind of frozen music, standing waves of energy that happen to persist. That is not a metaphor Wilczek invented for general audiences. That is his technical description of what the equations say. So what are you? You are a geometry of nearly nothing, animated by the motion of nearly massless objects, held in a pattern by forces you cannot see or feel directly. The chair you are sitting in right now is the same construction, the floor beneath it, the walls around you. Everything your senses interpret as solid is the same arrangement of void and vibration. Your sense of solidity, every experience of the physical world you have ever had, is your nervous system's interpretation of force interactions between arrangements of almost nothing. The Standard Model describes this with perfect accuracy. It predicts those force interactions, those quark motions, those gluon fields, to 11 decimal places. It is the correct description of what you are made of. And it is, by the admission of everyone who built it, an incomplete one. So what is the complete description of what you are? If 98% of your mass is energy of motion, and the theory that explains that motion is known to be missing enormous pieces of reality, what is actually holding the pattern together? What are you really? Under a complete theory we do not yet have. Think about the last time you touched something, your hand on a doorknob this morning. your feet on the floor when you got out of bed, the keyboard or phone in your hands right now. Every one of those sensations, every single experience of physical contact you have had in your entire life was a lie. A useful lie, an accurate lie in the sense that it predicted everything correctly, but a lie about what was actually happening at the physical level. Your hand never touched the doorknob. Your skin's electrons got close enough to the doorknob's electrons that the electromagnetic force between them pushed back. The sensation your brain interpreted as solid contact, the resistance, the texture, the hardness, was electromagnetic repulsion between electron clouds. You did not make contact with anything. You were repelled, and your nervous system translated that repulsion into the experience of touch. You have been living inside that translation your entire life without knowing it. The standard model predicts this with complete precision. The electromagnetic force, one of the four forces the model describes, is responsible for every sensation of touch, every structural property of matter, every chemical bond in your body. When the standard model calculates electromagnetic interactions, it gets the right answer to 11 decimal places every time. The theory of quantum electrodynamics, or QED, which describes how charged particles interact through electromagnetism, is the most precisely verified theory in the history of science. Richard Feynman, one of its architects, said it was like predicting the distance between New York and Los Angeles and being correct within the width of a human hair. Here is what makes this deeply troubling rather than merely interesting. The same theory that predicts your sense of touch with that extraordinary precision is the same theory that cannot account for what most of the universe is made of. The standard model is simultaneously the most accurate physical theory ever constructed and provably, demonstrably, structurally incomplete. Those two things are both true at the same time, and that combination is not a comfort, it is a warning. A theory that failed experiments would be easy to dismiss or replace. You would find the failure, identify the gap, build something better. But a theory that has never once failed an experiment and is still known to be wrong is a different kind of problem. The wrongness is not showing up in the numbers, it is showing up in the categories. The standard model is missing entire pieces of reality that it has no mathematical space to describe. Dark matter interacts gravitationally with everything we can see, bends light, shapes the large-scale structure of galaxies, constitutes roughly 27% of the total energy content of the universe. And the standard model has no particle for it, no field for it, no entry in its catalogue. The model's catalogue of particles is simply silent on the subject. So every time you reach out and feel something solid, every time electromagnetic repulsion tells your nervous system that the world is made of hard, real, touchable things, you are experiencing the output of a theory that is both perfectly accurate and fundamentally incomplete. The thing doing the touching is built from void and motion. The theory describing that touching is missing most of the universe, and your hand still feels the doorknob. What does it mean that the most accurate scientific theory ever written is still wrong? It means the universe is doing something more complex than the best equations we have can capture. And the part it is doing that the equations cannot capture, that missing portion, is most of what exists. As you sit there, right now, held to the floor by gravity that the standard model cannot fully describe, touching surfaces through a force the model describes perfectly but incompletely. What are the odds that the rest of it, the hidden 95%, is something we are anywhere close to understanding? As you sit there, right now, you are being shot through by things you cannot feel. The number is large enough that it stops being abstract and starts being physically disturbing. 10,000 muons, heavy cousins of the electron created when cosmic rays from distant supernovas slam into the upper atmosphere 60 miles above your head, pass through every square meter of your body every single minute. They travel at close to the speed of light. They pass through the walls of your room, through the roof above you, through the air between the ceiling and your skull, through your skull, through your brain, through every organ in your chest, through the floor, through the ground, and out the other side. You cannot feel them. You cannot stop them. You have no sense organ that responds to them, no reflex that registers their passage, no physical process in your body that meaningfully interacts with them. They simply pass through you as if you are not there, because to them, you barely are. That number, 10,000 per square meter per minute, is the measured rate at sea level. If you are inside a building, the walls reduce this by almost nothing. If you are in a basement, the reduction is small. If you descended to the deepest mine on Earth, more than 2 miles underground, you would cut the rate significantly, but you would not stop it. The muons come from the sky, and they come through everything. But muons are not the main event. 65 billion neutrinos pass through every single square centimeter of your body every second. Not per minute, per second, not per square meter, per square centimeter. 65 billion. These come from our star, from the nuclear fusion reactions happening 93 million miles away, which produce neutrinos in quantities so enormous that even at that distance, the flux through your body is incomprehensible. Those solar neutrinos are passing through you right now, in daylight and in darkness, because the Earth itself does not stop them. At night, they come up through the planet from below you and out through your body from the ground up. The Earth is not a barrier to them. It is a thin sheet of nothing. The Standard Model describes neutrinos. It was the Standard Model's own equations that first predicted them from the mathematics of beta decay in atomic nuclei, decades before any experiment detected one. When physicists finally captured the first neutrino interaction in 1956, they found exactly what the equations predicted. The model was right. And then, 42 years later, the model was proven wrong about neutrinos in a way that shattered a core assumption built into the theory from the beginning. We will reach that moment in a few chapters. Hold it in the back of your mind. For now, the point is this: your body is not an object in the ordinary sense. It is a geometry of forces that is nearly transparent to most of what the universe is made of. 65 billion neutrinos pass through each square centimeter of you each second and interact with essentially nothing. Every cell in your body is being threaded through continuously by particles carrying energy from the core of a star, 93 million miles away, and your body registers none of it. You feel nothing. Your cells do not respond. The particles do not notice you. The Standard Model predicts all of this correctly. The flux numbers, the interaction rates, the penetration depths, all of it matches the equations. The theory is right about every measurable thing happening to your body right now, and the theory is broken. The particles passing through you without touching, you are governed by equations that are, officially and provably, a fragment of something larger. Those 65 billion neutrinos per square centimeter per second are carrying information from a process that the Standard Model partly describes and partly does not. The universe is not designed for you to perceive it. Most of what is happening to your body at this moment is invisible to every sense you have. Most of what exists in the universe is invisible to every instrument we have built. You are a filter that catches almost nothing, living in a reality that the best theory we have describes only partially. What else is passing through you right now that the incomplete theory has no category for? Here is the fact that should have made your existence impossible. The Big Bang, the event that created everything, did not create matter. It created equal quantities of matter and antimatter. Equal. For every quark produced, an antiquark. For every electron, a positron. For every particle carrying mass and charge and the potential to become an atom, a mirror particle carrying identical mass and opposite charge, designed by the laws of physics to find its partner and annihilate. When matter meets antimatter, both cease to exist. The energy is released as photons, light, radiation. Nothing material survives the meeting. In the earliest fractions of a second after the Big Bang, The universe was dense enough that every particle was constantly finding its antimatter partner and annihilating. If the initial quantities were truly equal, and every equation we have says they were, then the annihilation should have been total, complete. The universe should have become a vast, cold sea of photons, energy without structure, radiation without matter, expanding forever into a void with nothing in it. No atoms, no stars, no planets, no chemistry, no life, no you. The fact that you exist is a sign that something went wrong, or rather, something went asymmetrically right in a way that the standard model cannot explain. For every billion matter-antimatter pairs that annihilated in those first moments, one extra particle of matter survived. 1 per billion annihilations. A single particle of matter with no antimatter partner, a leftover with no clear reason for its survival. Those survivors, that 1 in a billion residue of an almost perfect annihilation, became everything. Every atom in the universe, every star, every planet, every human body, all of it is the remains of a catastrophic destruction that was almost complete. The technical name for this is baryogenesis, the process by which more matter than antimatter came to exist. The standard model cannot produce it. Physicists have known this for decades. The model requires a specific violation of symmetry between matter and antimatter, a property called charge parity violation, and while the standard model does contain some charge parity violation, it contains nowhere near enough to produce the matter-antimatter asymmetry we observe. The measured asymmetry requires a mechanism the current theory simply does not have. Some process happened in the first fractions of a second after the Big Bang that generated a matter surplus, and the standard model, the most precisely tested theory in history, cannot produce that surplus no matter how the equations are arranged. Physicists like Andrei Sakharov laid out the conditions required for baryogenesis in 1967. The conditions are clear. The standard model meets some of them and fails others by margins so large they cannot be papered over. The theory predicts almost perfect annihilation. The universe produced you instead. Hold the full weight of that. You are sitting there right now because one particle in every billion survived a destruction that the physics governing you says should have been absolute. The law you obey could not have produced you. The law is right about everything in the laboratory. It is wrong about the fact of your existence. Every atom in your body is a violation of what the best equations we have would have predicted for the universe. The standard model is not missing a small correction at the edges. It is missing the explanation for why there is anything at all. If you ran the standard model as a simulation and started it at the Big Bang, the universe it produces is empty. You are the evidence of the error. You are the proof that something is in the equations we have not found yet. So what found you? What process wrote the rule that spared one particle per billion and made everything possible? And if that rule is not in any textbook currently written, what else is the universe doing that we have not found the equation for? In 1998, physicists studying particles called neutrinos made a discovery. It was clean, it was unambiguous, and it was a direct, undeniable contradiction of a prediction the standard model had been making for decades. The standard model said neutrinos were massless. The word massless is not a hedged estimate. It is a structural feature of the theory, built into its mathematical framework. In the standard model, as originally constructed, neutrinos have no mass. The equations require it. The standard model is not a collection of estimates and approximations where one number being wrong is a minor embarrassment. It is an internally consistent mathematical structure, and the prediction of massless neutrinos was not an assumption bolted on loosely at the side. It was embedded in the core of the theory. Then the Super Kamiokande experiment in Japan published its results. The experiment, a vast tank of 50,000 tons of ultra-pure water buried deep in a Japanese mine and instrumented with thousands of light detectors, was measuring neutrinos produced in the atmosphere by cosmic rays. The physicists found something wrong. Neutrinos were changing. A neutrino produced as one type was arriving at the detector as a different type. This process, called neutrino oscillation, is only possible if neutrinos have mass. Massless particles cannot oscillate. The equations forbid it. Massless particles also travel at the speed of light. At the speed of light, time dilation is complete. From the particle's frame of reference, no time passes at all, and there is no mechanism for one type to transform into another. Neutrino oscillation requires time. Time requires mass. The measurement was clear. Neutrinos have mass. The Nobel Prize in Physics was awarded in 2015 to Takaaki Kajita and Arthur MacDonald, who led the experiments that confirmed this. The Nobel Committee did not describe the finding as a refinement or an extension of the Standard Model. The finding was explicitly and formally described as evidence that the Standard Model is incomplete. The most prestigious scientific prize in the world was awarded for proving that the most successful physical theory in history has a structural defect at its core. Consider what that means. The Standard Model had passed every test ever designed for it. Its predictions matched experiments to 11 decimal places. Physicists had built particle accelerators costing billions of dollars to test it, and every time, the theory won. And then, in a tank of water in a Japanese mine, it lost. The particles it said were massless had mass. The feature it said was impossible was happening continuously in the atmosphere above your head, in the 65 billion neutrinos per square centimeter per second passing through your body right now. Every neutrino passing through you at this moment is oscillating, changing type, demonstrating mass, violating, in an ongoing and continuous way, the prediction of the theory that governs the particles doing it. The Standard Model is abstractly incomplete in some distant cosmological sense, yes, but the incompleteness is also immediate and present. It is wrong about what is happening to your body right now, in real time, as you sit there. The theory was rewarded for being right about everything and wrong about this. The Nobel Prize did not force a replacement. No new theory stepped in. Physicists patched the Standard Model with an extension, an add-on, a modification that accounts for neutrino mass without replacing the underlying structure. The house had a crack in the foundation. They repainted the wall and called it fixed. If the most awarded, most tested theory in history can be wrong about a basic property of a particle passing through your body 65 billion times per second per square centimeter. What else is it wrong about that we have not yet found the experiment to reveal? Freeman Dyson helped build quantum electrodynamics, the QED, that forms the mathematical heart of the Standard Model's description of electromagnetism. He was one of its architects. He worked alongside Feynman and Schwinger to turn their brilliant but formless insights into a coherent mathematical structure. He understood the theory as well as any human being alive. In 1979, Dyson wrote something that physicists have been quietly aware of ever since. He pointed out that quantum electrodynamics is what is technically called a divergent series. The way the theory produces its extraordinarily precise predictions is through a process of calculating corrections to corrections to corrections, an infinite series of terms that, taken together, gives the right answer. But taken to its logical conclusion, the series does not converge. It diverges. It blows up. The predictions that match experiments to 11 decimal places are not the result of a theory that settles into a stable answer as you add more terms. They are the result of stopping the calculation at a point where the divergence has not yet made itself apparent. Dyson's original comment was blunter. In private correspondence and lectures from the 1940s and 1950s, when quantum electrodynamics was new and its architects were aware of its structural fragility, Dyson characterized it as a jerry-built structure, a phrase meaning something constructed hastily and without proper foundations. He expected it to be replaced within a decade. That was 1949. More than 75 years have passed. The jerry-built structure is now the theoretical foundation of the transistor. Every computer chip on Earth, every processor in every phone, in every server running every piece of software in the modern economy operates on semiconductor physics, whose deep theoretical basis is quantum electrodynamics, lasers, MRI machines, the solar panels generating electricity. Every technology involving controlled light-matter interaction at the quantum level sits on a mathematical framework that its co-inventor described as temporary. The structure works. That is, the impossible part. A theory its own architect expected to survive 10 years has instead survived long enough to become the invisible infrastructure of civilization. Every time you use a phone or receive an MRI or fly in a plane with solid-state electronics, you are depending on a jerry-built structure that has refused to break. But Dyson's concern was not whether the predictions were accurate. His concern was whether the mathematical foundation was sound. Accurate predictions and a sound foundation are not the same thing. A theory can give you the right answer for the wrong reasons, or through a mechanism that is stable under the conditions you have tested but fragile under conditions you have not yet reached. Quantum electrodynamics gives right answers at the energies and scales we can currently test. Whether it gives right answers at higher energies, at shorter distances, in regimes we have not yet probed, is a question its mathematical structure cannot answer with confidence. The Large Hadron Collider at CERN is probing those higher energies. It is running collisions at scales where the jerry-built structure begins to face conditions its architect doubted it was built for. The data coming out of those collisions is the reason this video exists. CERN is not finding a routine confirmation of old predictions. It is finding anomalies, edge cases, places where the predictions and the measurements pull apart. The structure is showing its age. The man who built it told us this would happen. He told us it was temporary in 1949. And for 75 years we built everything on it anyway because nothing better was ready. Now, something may be pushing through the cracks that he always knew were there. Are you comfortable sitting inside a civilization whose theoretical foundations were called jerry-built by the person who built them? In 1998, two independent teams of astronomers were measuring how fast the universe's expansion was slowing down. Every physical model available predicted that gravity, acting across cosmic distances on all the matter in the universe, was pulling the expansion back, decelerating it, slowing the outward rush that began at the Big Bang. The question was not whether it was decelerating. The question was how much. Both teams, the High Z Supernova Search Team and the Supernova Cosmology Project, working independently, using different telescopes and different methods, arrived at the same answer. The expansion was not decelerating. It was accelerating. The universe was not slowing down under gravity's pull. Something was pushing it outward, faster and faster, and that something was getting stronger as the universe grew larger. Saul Perlmutter, Brian Schmidt, and Adam Rees received the Nobel Prize in Physics in 2011 for this discovery. The Nobel Committee described it as among the most unsettling findings in modern cosmology. Physicists named the unknown force dark energy because they had no idea what it was and needed a name that communicated the depth of their ignorance without overstating what they understood. Dark energy is a placeholder. It is what you call a thing when you have measured its effects precisely and have no explanation for its nature whatsoever. The measured quantity is this. Dark energy constitutes 68% of the total energy content of the universe. The matter you can see, stars, galaxies, gas clouds, everything your telescopes have ever detected, constitutes roughly 5%. Dark matter, the invisible mass whose gravitational effects shape galaxies, constitutes 27%. The thing doing the work, the thing accelerating the expansion of everything in every direction, the thing constituting more than 2/3 of all the energy in existence, is something the Standard Model has no particle for, no field for, no equation for. The Standard Model describes 5% of the universe with extraordinary accuracy. The other 95% it is silent on. Dark energy is not a small gap in the theory. It is the dominant feature of the universe, and the theory that governs your body treats it as if it does not exist. As you sit there right now, dark energy is at work. The distance between your galaxy, the Milky Way, and the next large galaxy, Andromeda, currently about 2.5 million light-years, is growing. Every large-scale cosmic distance is growing. The universe is not expanding into something, because space itself is expanding, pulling those distances open. Dark energy is the engine of that expansion, and it operates continuously, in every direction, at every scale above a certain threshold. Your atoms are not being pulled apart by it, because gravity and electromagnetism dominate at the scale of atoms. But the universe as a whole is being pushed apart, faster than it was yesterday, faster tomorrow than it is today, by something that is not in the equations that govern those same atoms. The theory is right about the small things and silent about the largest thing. Your body obeys equations that ignore 68% of what the universe is made of. Every calculation that has ever been done to predict the behavior of matter leaves out the dominant energy content of existence. What is dark energy? After more than 25 years, the answer is still the same. We do not know. The name is not a description. The name is an admission. Something is accelerating the expansion of everything, constituting 68% of all energy in existence. And the best physics we have has nothing to say about what it is. How much does not knowing 68% of the answer change your confidence in the 32% you think you understand? There is an equation. It comes from quantum field theory, the mathematical framework underlying the Standard Model. The equation calculates the energy density of empty space, the amount of energy contained in a perfect vacuum with no matter, no radiation, nothing. In quantum mechanics, empty space is not empty. It seethes with virtual particles, pairs of particles and antiparticles flickering into and out of existence on timescales too short to directly detect, carrying energy that is real and measurable in its effects. The equation adds up all those contributions and produces a number, the measured value of the vacuum energy density. The actual number derived from cosmological observations is 10 to the power of 120 times smaller than what the equation predicts. 1 followed by 120 zeros. That is the ratio between what the theory says should be there and what is actually there. Put that number in terms your intuition can reach. If you predicted the distance from your front door to the corner store and were wrong by the same factor, your predicted distance would extend past the edge of the observable universe, and then some. If you predicted the number of sand grains on every beach on Earth and were wrong by this factor, the number you gave would exceed the number of atoms in the observable universe by margins beyond any image your mind can form. This is the largest discrepancy between a theoretical prediction and a measured observation in the entire history of science. Every other prediction in every other field of science, including the most wildly incorrect estimates ever published, falls orders of magnitude short of being this wrong. The prediction is not the result of a sloppy calculation. Quantum field theory is mathematically rigorous. The calculation is correct within its own framework. The framework and reality disagree by a factor so large that the word error does not cover it. Physicists call it the cosmological constant problem, a name that makes it sound like a manageable technical issue. It is something closer to the theory pointing at a sky that is completely filled with stars and the universe handing back a photograph of near total darkness. Something is cancelling the vacuum energy. Something is taking the enormous predicted value and reducing it to a number 120 orders of magnitude smaller, with a precision that has no explanation in any existing theory. The cancellation is not approximate. It is precise to 120 decimal places. Whatever is doing the cancelling knows the answer to the calculation and is subtracting it out, leaving only an infinitesimal residue, and doing so with a precision that makes the best measurement instruments humans have ever built look crude by comparison. Physicists call this fine-tuning. They mean something specific by that term. Fine-tuning means the parameters of the universe are set to values that differ from the values that would produce a hostile universe for life by margins so small that any reasonable probability argument says they should not be set. This way, the vacuum energy cancellation is the most extreme fine-tuning problem in physics. The precision required is 120 decimal places. Achieving that by accident, in a universe that has no designer and no preference for the outcome, is not merely unlikely. It is a number so small that saying unlikely is an insult to the scale of the problem. What is doing the cancelling? The standard model does not have a mechanism for it. String theory proposes possibilities, but none have been tested or confirmed. Supersymmetry was a candidate, but after years of searching at the Large Hadron Collider, no supersymmetric particles have appeared. The answer is not in any current theory. The most important precision in the universe, the one that makes atoms stable, that makes matter possible, that makes you real, is being maintained by something no equation in any textbook describes. Is that precision something you are comfortable not understanding? The vacuum energy cancellation is not a solved problem filed away in the history of physics. It is happening right now. As you sit there, the energy density of the space you occupy, of every cubic centimeter of the room you are in, is being held to a value 120 orders of magnitude below what the quantum field theory equations predict it should be. The mechanism producing that precision is operating continuously, in every location in the universe, at every moment. It is not a historical event. It is a present tense feature of reality that is active and ongoing and making your existence possible as you breathe. Your atoms hold together because the conditions that allow atoms to hold together are being maintained. The electromagnetic force has the strength it has because the underlying vacuum is stable at the value that gives electromagnetism that strength. If the vacuum energy were anywhere near its predicted value, the curvature of space would be so extreme that atoms could not form. Protons and electrons would be flung apart before electromagnetism could bind them. Matter, as a stable configuration, would not be possible. You would not exist, not because something destroyed you, but because the conditions required for your type of organization would never have been achievable. Something is maintaining those conditions. Something is keeping the vacuum energy at the precisely calibrated value that makes atoms possible, that makes stars possible, that makes planets possible, that made the particular chain of events leading to you possible. The standard model, the theory running every particle in your body, does not describe that something. It has no entry for it, no field, no particle, no force in the standard model's catalog is responsible for the precision that makes the standard model's own predictions about particles meaningful. Think about what that means structurally. The theory governing your particles is only able to make correct predictions because some external stabilizing mechanism, unknown to the theory, is maintaining the conditions under which the theory's predictions hold. The standard model works because something the standard model cannot see is keeping the ground beneath it stable. Physicists have known this since the 1980s, when the cosmological constant problem was formally articulated. They have proposed candidates, a field called quintessence that slowly changes the vacuum energy over cosmic time, a landscape of possible universes, each with different vacuum energies, selected by the anthropic principle. Supersymmetry, which would naturally cancel the vacuum energy contributions through a symmetry between matter particles and force particles. Every proposal has failed to produce a testable prediction that matches observation, or has produced a testable prediction that was tested and came back empty. The Large Hadron Collider was built in part to find the supersymmetric particles that would explain the cancellation. At energies where supersymmetry predicted those particles would appear, the data came back with nothing. Thousands of physicists, billions of dollars of equipment, the most energetic particle collisions ever produced by human technology, and the answer was silence. The stabilizing mechanism is real. It is operating right now in every cubic centimeter of your room, and we have no idea what it is. Stop there for a moment. The The standard model fails to explain the origin of matter, the nature of dark energy, and the mass of neutrinos. But the failure goes even deeper than that. It fails to explain the most basic precondition for its own applicability. The theory that governs your atoms requires that the vacuum be stable, that the energy of empty space be maintained at an impossibly precise value. As a background condition, remove that stability and the atoms the theory describes could not exist. The theory depends on a flaw it cannot see and cannot explain. Your existence is sitting on top of the standard model, and then something deeper still. Your existence is sitting on top of something the standard model sits on top of, something unnamed and undescribed in any current framework, something maintaining precision to 120 decimal places at every point in space, at every moment in time. The standard model does not explain why the universe is hospitable to matter. It assumes hospitability and builds from there. The explanation for why matter is possible at all is not in any equation that has ever been written down. As you sit there right now, that unknown stabilizing mechanism is operating beneath your feet, beneath every atom in your body, beneath the particles the standard model describes. Something is holding the conditions for your existence open. We do not know what it is. We do not have a theory for it. And until we do, the deepest answer to the question of why you exist is this: because something we cannot describe is allowing it. And yet, the theory that cannot describe what is holding your existence open also cannot describe most of what exists. Here is the accounting, laid out plainly. The standard model, the framework that catalogues every particle your body is made of, every force that holds those particles together, every interaction that has ever been observed in a laboratory, accounts for approximately 5% of the total mass energy content of the universe. 5%. The remaining 95%, the overwhelming majority of everything that exists, is composed of substances the standard model has never seen, cannot describe, and has no mechanism to explain. 26% of the universe is dark matter, a label physicists use for mass that exerts gravitational pull but emits no light, reflects no light, and interacts with the electromagnetic force through no known channel. 68% is dark energy, a label for whatever is causing the expansion of the universe to accelerate rather than slow. Both are called dark because we see none of them, understand none of them, and the theory that runs every calculation in modern physics contains no equation for either. Pause on that proportion for a moment. If you were given a map of a city and told it accurately charted 5% of the streets, you would not call it a map of the city. You would call it a sketch of a neighborhood inside a city whose shape you cannot see. The standard model is that sketch. It is extraordinarily precise within its 5%. Every number it predicts matches measurement to a degree of accuracy that humbles every other scientific achievement in human history. Every charged particle interaction, every nuclear decay rate, every force measured in a laboratory confirms it down to the 12th decimal place. And it describes a universe that is 95% invisible to it. Consider what that actually means for the world you inhabit. Your atoms are standard model territory, a tiny island of legible, describable matter. The galaxy your planet orbits is held together by dark matter's gravitational grip, a scaffolding the standard model cannot account for, cannot model, cannot even define. Without that scaffolding, the Milky Way would fly apart. The stars above you tonight, the arrangement of the sky you take for granted as a fixed backdrop, exist in their current configuration because of something the best theory in the history of human science has never detected and has no language to describe. Your existence depends on the coherence of a galaxy shaped by matter the theory of matter has never seen. The standard model is not a slightly incomplete picture. It is a picture of 5% of a painting, framed and labeled as a masterpiece. The other 95% of the canvas is behind the frame, and every tool the standard model provides for looking is blind to whatever is back there. Physicists have known this for decades. They have incorporated this knowledge into cosmology, into the design of experiments, into their grant applications and their conference presentations. And the fact that this has become routine, that 95% unknown can appear in a sentence without stopping anyone in their tracks, may be the most disturbing normalization in the history of science. The theory running your body describes a universe it cannot read. And this has been true for your entire lifetime, and your parents' lifetimes, and every lifetime before them, since the discovery of dark matter in the 1930s. We have known the map was wrong for nearly a century. We have not replaced it. What does it mean to live in a universe whose primary feature is invisible to every tool you have? Right now, as you sit there, dark matter is moving through you. Say that plainly. It is the expected consequence of what dark matter is, a physical prediction, not a rhetorical device. Because it interacts with ordinary matter through gravity and, as best we can determine, nothing else. It passes through walls, floors, human bodies, and the entire bulk of the Earth, as though none of those things are meaningfully present. The Earth is not a barrier to dark matter. The Earth is a transparency. At this moment, a stream of dark matter, whether particles or something else entirely, is flowing through the room you occupy, through the walls around you, through the floor beneath you, through the specific arrangement of atoms that constitutes your body, your organs, your brain, the tissue generating your thoughts right now. Every cell in your body, every moment of your life, since before you were born, has been continuously penetrated by matter we cannot see, cannot stop, and cannot touch. The universe has been moving through you without your permission or knowledge from the first moment you existed. No detector on Earth has confirmed a single direct interaction between a dark matter particle and a single atom of ordinary matter. The experiments built to find that interaction are extraordinary feats of engineering, machines of almost absurd sensitivity. Deep underground mines in South Dakota and Italy and Canada house tanks of liquid xenon, cooled to temperatures within fractions of a degree of absolute zero, surrounded by layers of shielding that block out cosmic rays and background radiation, watched over by sensors capable of detecting energy depositions smaller than the tiny vibration of a single atom. The Xenon 1T experiment at the Gran Sasso National Laboratory in Italy ran for 279 days with 1 ton of liquid xenon, searching for the faint recoil that would occur if a dark matter particle struck a xenon nucleus. It found nothing. Its successor, Xenon NT, uses 3 times the xenon and is more sensitive by an order of magnitude. It is finding nothing. The Lux Zeppelin experiment at the Sanford Underground Research Facility in Lead, South Dakota, currently the most sensitive direct detection experiment in history, has found nothing. Experiment after experiment, each one more sensitive than the last, each one eliminating more of the theoretical space where dark matter could hide, each one returning the same answer. There is a possibility physicists discuss with increasing openness. It is possible that dark matter interacts with ordinary matter through no force other than gravity. At any strength, any instrument we can ever build will be capable of detecting. Every direct detection experiment is based on an assumption that dark matter has some small but non-zero interaction with standard model particles beyond pure gravity. If that assumption is wrong, if dark matter is gravitationally coupled and nothing else, then no terrestrial detector will ever register its presence, regardless of how sensitive we make it. The dark matter flowing through your body right now may be permanently, fundamentally beyond the reach of experimental physics. We might be able to map its gravitational effects on galaxies forever and never learn what it is made of, never learn if it is particles at all, never answer the most basic question of what composes the majority of the matter in the universe. It moves through you constantly. It has moved through every human who has ever lived, and the honest answer to what it is may be something physics has rarely been forced to say about anything. We will never know. For 40 years, physicists were certain they already knew. They were not operating in uncertainty. They had a framework, a candidate, a mathematical structure of compelling elegance that seemed to solve several problems simultaneously and delivered dark matter as a natural consequence. The framework was called supersymmetry, and for 4 decades, it was the dominant theoretical paradigm for physics beyond the standard model. Supersymmetry proposed that every known particle has a partner particle with different spin properties. The electron has the selectron, the quark has the squark, the photon has the photino, the Higgs boson has the Higgsino. These partners were predicted to be heavier than their known counterparts, which explained why no experiment had seen them yet. They were accessible, the theory said, at energies just above what existing accelerators could reach. Build a machine powerful enough, and you would find them. And crucially, the lightest supersymmetric particle, in most versions of the theory, a particle called the neutralino, was predicted to be stable, electrically neutral, and weakly interacting. It would not decay. It would not emit light. It would pass through ordinary matter with near zero interaction. It fit the profile of dark matter so precisely and so naturally that many physicists considered it overwhelming evidence of supersymmetry's truth. They called it the WIMP miracle, the observation that a particle predicted for entirely different theoretical reasons also happened to produce the right amount of dark matter in the early universe automatically. 2 separate motivations pointing at the same answer seemed too perfect to be coincidence. Thousands of physicists built careers on the framework's predictions. Graduate students chose dissertation topics in the corners of supersymmetric parameter space. Senior theorists wrote textbooks. Experimental collaborations designed detectors specifically calibrated to the signatures supersymmetric particles would produce. The Large Hadron Collider at CERN, the most expensive scientific instrument ever constructed, was built partly on the expectation that supersymmetric particles would appear at the energies it could reach. Supersymmetry was not fringe thinking or wishful speculation. It was the consensus of theoretical physics for a generation. Senior physicists debated which supersymmetric particle the Large Hadron Collider would discover first. The question was not whether, it was when. The Large Hadron Collider found no supersymmetric particles. After years of collisions at energies and rates that should have produced them, if they existed in the mass ranges the most natural versions of supersymmetry predicted, the data returned nothing. Each search covered more parameter space. Each result came back empty. The mass windows where supersymmetric particles were most theoretically motivated were systematically ruled out one by one. The neutralino, the dark matter candidate that had seemed like a miracle of coincidence, was not there. The theoretical structure that had organized particle physics for 4 decades, shaped by thousands of careers, motivated in part by the design of a machine that cost over $10 billion to build, appears not to correspond to physical reality. The 40-year certainty was wrong. What does a field do when the framework it built an entire generation of physicists around turns out not to exist? Let's be precise about what happened at the Large Hadron Collider, because the precision matters and it is easy to miss what is actually disturbing here. The machine was not built only to find supersymmetry. Its primary stated mission was to discover the Higgs boson, the final predicted but unconfirmed particle of the standard model, the field that gives other particles their mass, predicted since 1964 and never directly observed. On July 4, 2012, physicists at CERN announced its discovery. The observation was clean. The signal was unmistakable. The statistical significance was overwhelming. Peter Higgs, who had written the theoretical paper in 1964, was in the audience. He wept. The standard model was complete. Since that day, in over 15 years of operation at energies higher than any accelerator in human history, the Large Hadron Collider has found 0 particles beyond the standard model, 0 new forces, 0 anomalies that cannot be explained within the existing framework. The machine has accumulated more collision data than was collected in all previous particle physics experiments in history combined. It runs at energies of 13 trillion electron volts, energies that should produce new physics if new physics exists at scales that could explain the hierarchy problem or the nature of dark matter. The detectors are marvels of engineering, capable of reconstructing particle trajectories with micrometer precision. Millions of collisions are analyzed every second. The data is unambiguous. Every measurement matches the standard model. Every time. The most powerful microscope humanity has ever built looked at the deepest accessible layer of physical reality and found exactly, precisely, only what the existing theory already predicted, and nothing more. The machine that was supposed to open a door found only a wall, and the wall is the standard model itself, the same theory that cannot account for 95% of the universe, that has no explanation for dark matter or dark energy, that cannot explain why the Higgs mass is stable or why any constants have the values they do. The silence since 2012 is not the silence of a completed project, a mission accomplished and a frontier closed. It is a different kind of silence. The kind that falls in a room when everyone present realizes that the door they came to open is not here and nobody knows where to look next. If the physics that explains the 95% of the universe the standard model cannot describe is not accessible at the energies the Large Hadron Collider can reach, then the next machine would need to be orders of magnitude more powerful, orders of magnitude more expensive, and there is no political or economic path to building it. The silence since 2012 may be the sound of physics approaching a wall it cannot climb. In December of 2015, that silence appeared to break, and what happened next is one of the most instructive episodes in the recent history of science. Not because of what was found, but because of what was not. Physicists analyzing preliminary data from the Large Hadron Collider's ATLAS detector and the compact muon solenoid detector noticed an excess of events at an energy of 750 billion electron volts. 2 photons being produced simultaneously at that energy, more frequently than the standard model predicted they should be. The excess appeared in both detectors independently, which reduced the probability that it was an artifact of a single instrument. Statistically, the signal was not yet definitive, roughly 3 sigma in each experiment, but the combination and the fact that 2 separate detectors saw the same anomaly was enough to generate serious discussion. Physicists began presenting the results at conferences. Word spread through the community. What followed was extraordinary. Before the full dataset was analyzed, before any peer review had occurred, before anyone had time to scrutinize the analysis carefully, the theoretical physics community mobilized with remarkable speed. Within weeks, over 500 papers had been submitted to Arxiv, the online preprint server where physicists share results before formal publication, each one proposing an explanation for the excess, each one theorizing about the properties of the new particle the bump might represent. The hypothetical particle acquired names in informal discussions. Its decay modes were calculated. Its implications for supersymmetry, for models with extraspatial dimensions, for various extensions of the standard model, were explored in exhaustive detail. Entire new theoretical architectures were constructed on the foundation of a histogram feature that had not been verified by anyone. The community had been waiting so long for any signal beyond the standard model, starved of new physics for 3 years since the Higgs discovery, that when something appeared in the data even tentatively, the collective response was to immediately build a city on it. In the summer of 2016, the full dataset from the Large Hadron Collider's Run 2 arrived. The excess at 750 billion electron volts was gone. It had been statistical noise, a random fluctuation that appeared significant at low data volumes and vanished as more data accumulated, precisely as statistical fluctuations do. There was no new particle. 500 and more papers were instantly obsolete. Careers had been redirected. Conference sessions had been restructured. and the entire mainstream of theoretical particle physics, the community of thousands of trained experts whose function is to model physical reality, had spent months developing detailed explanations for something that did not exist, without any mechanism to know that was what they were doing. Right now, as you sit there, the theoretical community is generating papers about anomalies in current data. Some of those anomalies are real. Some are noise. Nobody can yet tell which is which. How many of those papers will be the next 500? The diphoton episode was acute. A sharp excitement resolved in months when new data arrived. What came next was slower, quieter, and in some ways more disturbing precisely because it persisted. Beginning around 2014, the Large Hadron Collider beauty experiment at CERN published a series of measurements on the decay of particles called B-mesons, unstable composites containing a bottom quark. The standard model makes precise predictions about how B-mesons decay into different combinations of lighter particles. The measurements showed deviations from those predictions. Small ones, typically around 3 sigma, below the 5 sigma threshold the field uses to claim a discovery, but consistent. They appeared across multiple different decay channels. They persisted through multiple rounds of data collection. They reproduced. Hundreds of papers were written, exploring what kinds of new physics could explain a coherent, multi-year pattern of B-meson anomalies. Some physicists were careful. Others were more enthusiastic. A few senior voices began discussing whether the B-meson sector was showing the first genuine cracks in the standard model. The anomalies had lasted long enough and appeared in enough different measurements to seem like something real. In 2022, the Large Hadron Collider Beauty Collaboration released an updated analysis of the same measurements. Every anomaly disappeared. The new results were in agreement with the standard model across every decay channel that had shown deviations. The apparent new physics was gone. What happened was not that new data contradicted the anomalies. What happened was a flaw in the analysis itself, a systematic error in how the experiment modeled and subtracted certain background processes from the signal. That flaw had been present from the beginning. It had been embedded in the analysis framework and applied consistently across every measurement for years, generating a coherent pattern of deviations that was not a feature of the data but a feature of the method. For years, physicists were not measuring B-meson decays. They were measuring the consequence of an error in their own analysis and interpreting it as evidence of physics beyond the standard model. The standard model was correct throughout. The instruments were functioning correctly throughout. The numbers being reported were wrong because the assumptions baked into the analysis software were wrong, and those assumptions had been propagating undetected for years across dozens of papers. The B-meson case is not simply a story about a mistake that was eventually corrected. It is a demonstration of something structural. Modern particle physics experiments are so complex that the analysis of their data is inseparable from theoretical assumptions built into the reconstruction software. The measurement and the model are entangled. An error in the model does not produce an obvious discrepancy. It produces a systematic bias that generates consistent, reproducible, apparently significant results in the wrong direction for years before anyone with enough expertise and enough time realizes what has happened. How many other analysis frameworks in experiments running right now contain propagating errors that are producing consistent, apparent signals nobody has yet identified as artifacts? Then came an anomaly that could not be dismissed as noise or analysis error because the experiment was too careful, the significance too overwhelming, and the result too precisely characterized. And yet it cannot be true, and nobody knows why. In April of 2022, the collider detector at Fermilab collaboration published the most precise measurement of the W boson mass ever achieved by any experiment. The W boson is one of the carrier particles of the weak nuclear force, one of the 4 fundamental forces of nature, responsible for radioactive beta decay and for the nuclear processes powering the cores of stars. The Standard Model predicts its mass with extraordinary precision. The collider detector measurement incorporated over 1 decade of data collection, representing tens of billions of recorded collisions, and a meticulous analysis refined over years. The collaboration's result was 80.4337 billion electron volts. The Standard Model prediction is approximately 80.357 billion electron volts. The discrepancy is 7 sigma. 7 sigma. Under the established standards of particle physics, 5 sigma is a discovery. The probability of a 5 sigma result arising by chance, if the theory is correct, is roughly 1 in 3.5 million. 7 sigma is an incomparably stronger statement. Under any conventional interpretation, the collider detector result is not a hint, not an anomaly to monitor, not a tantalizing fluctuation. It is proof. It is, by every metric the field has developed over decades, ironclad experimental evidence of physics beyond the Standard Model. The Atlas experiment at CERN measured the W boson mass independently and published a result consistent with the Standard Model. The compact muon solenoid experiment at CERN measured the W boson mass independently and published a result consistent with the Standard Model. 3 separate experiments, each built by thousands of physicists, each analyzing independent datasets, each measuring the same physical quantity. 1 returns a 7 sigma deviation from theory. 2 return agreement with theory. No error has been found in the collider detector analysis. No error has been found in the Atlas or compact muon solenoid analyses. Matt Strassler, a physicist at Harvard who writes with exceptional care about experimental results, stated publicly that it is possible we will never know what went wrong, not that we will eventually figure it out. That we may never know. The W boson mass measurement is an open wound in the experimental record of physics. 3 experiments, 3 irreconcilable answers. One of them, possibly more than one, is wrong. And the community may be permanently unable to determine which or why. If we cannot resolve a 7 sigma disagreement between 3 of the most sophisticated experimental collaborations in the world, what does that say about every other measurement where the disagreements are smaller and the scrutiny less intense? Sit with that question for a moment. Really sit with it. The Standard Model is incomplete. Something is stabilizing the Higgs mass through an unknown mechanism. 95% of the universe is invisible to the theory. Supersymmetry, the leading framework for what lies beyond, produced nothing in 40 years and left no experimental trace. The most powerful accelerator in human history completed the Standard Model and then found nothing more. 500 papers chased a statistical ghost for months. 8 years of B-meson anomalies dissolved into a propagating analysis error. And a 7 sigma experimental result, the kind of result that under any normal scientific standard would constitute proof, sits in the literature irreconcilable with 2 independent measurements, with no identified cause and possibly no resolution ever. There is a question underneath all of this that physicists are now willing to ask in public, a question they would not have asked a decade ago. What if the Standard Model is not only incomplete, but what lies beyond it is not accessible to any instrument we can build? What if the tools capable of interrogating reality at the deepest level have reached a fundamental boundary, a point at which the complexity of the apparatus, the theoretical assumptions embedded in the analysis, and the irreducible difficulty of the measurement combine to produce irreconcilable results with no ground truth to adjudicate between them? The instruments are not simple. They are not telescopes pointed at something distant and passive. They are machines that create conditions that have not existed in the universe since fractions of a second after the Big Bang, detect the debris of those conditions through millions of electronic channels firing simultaneously, and reconstruct what happened using algorithms that depend on theoretical predictions for processes the Standard Model describes, applied to regimes where the Standard Model may be wrong. The measurement is built from the theory. If the theory is wrong at the scale being probed, the instrument does not simply fail to find new particles. It may produce systematically biased measurements that look precise and reproducible and significant and point nowhere real. The B meson case is a mild version of this. The W boson case may be a more severe version. And if this is structural, if it is a consequence of the depth at which physics is now operating rather than a correctable flaw in specific analyses, then the crisis has two faces. We do not know what lies beyond the standard model, and our method for finding out may be broken in ways we cannot fix. And yet the data keeps producing anomalies. One of them has been alive for years, and it is stranger than most because the experiment and the theory cannot agree on what the experiment is measuring. The muon is a particle like the electron, but approximately 200 times heavier. It carries the same electric charge and the same quantum numbers, but its mass places it in a different role in the particle spectrum. It is unstable, decaying into an electron and two neutrinos in about 2/millionths of a second. But in that brief window, it behaves as quantum mechanics predicts, and one of those predictions involves its magnetic properties. Every charged particle has a magnetic moment, a property describing how it responds to a magnetic field. For a simple point charge spinning in a field, quantum mechanics gives a specific prediction for the magnetic moment. But quantum field theory says that real particles are surrounded by clouds of virtual particles constantly popping in and out of existence, and those virtual particles affect the magnetic moment slightly. The deviation from the simple prediction is called the anomalous magnetic moment. For the muon, physicists call the measurement muon G-2. The standard model predicts the muon's anomalous magnetic moment to extraordinary precision, incorporating contributions from quantum electrodynamics, from the weak force, and from the strong force, through a process called hadronic vacuum polarization. The muon G-2 experiment at Fermilab measured the actual value. The first result, published in 2021, showed a discrepancy of 4.2 sigma between the measurement and the standard model prediction calculated by the community consensus at the time. Additional data pushed that discrepancy to 5.1 sigma, 5 sigma, by the field's own criteria. This is a discovery. The muon's magnetic moment is not matching what the theory says it should be. Something is interacting with the muon that the standard model does not account for. Then the BMW collaboration, a group of theoretical physicists using a computational technique called lattice quantum chromodynamics, published a calculation of the hadronic vacuum polarization contribution to the muon's anomalous magnetic moment. Their calculation used a different method than the community consensus. Their result was different. With the BMW prediction substituted into the comparison, the discrepancy between the Fermilab measurement and the standard model essentially collapses. By BMW's calculation, the muon is behaving exactly as it should, except the BMW calculation and the previous community consensus calculation disagree with each other. Both are calculations of the same physical quantity using the same underlying theory. They give different answers. The muon anomaly is simultaneously a 5 sigma discovery and no discovery at all, depending on which group of theorists has calculated the standard model prediction correctly. Physicists cannot resolve this by taking more data, because the disagreement is not between experiment and theory. It is between two versions of the same theory, two groups of skilled physicists applying the same framework to calculate the same number and arriving at different results. The measurement is not in question. What the measurement means is completely open. You are watching physics argue with itself about what its own equations predict, while a 5 sigma anomaly hangs in the middle, possibly pointing at new particles and new forces, possibly pointing at nothing at all, and nobody yet knows which. In 1917, Albert Einstein looked at the field equations of his general theory of relativity and found a problem. The equations, which described how matter curves space-time and how that curvature in turn shapes the motion of matter, predicted that the universe should be evolving, either expanding or contracting under the influence of gravity. Einstein, like everyone else at the time, believed the universe was static, eternal, and unchanging. A universe that was collapsing or expanding did not match the cosmos he observed or the cosmos he believed in. So, he added a term to his equations, a constant value associated with the fabric of space-time itself, a background energy density that would generate a repulsive effect precisely balanced against gravity, producing a stable, static universe. He called it the cosmological constant, represented by the Greek letter lambda. The modification worked mathematically. It was arbitrary in the sense that nothing in the underlying theory motivated its specific value, but it gave him what he needed. In 1929, Edwin Hubble completed a series of measurements showing that distant galaxies were moving away from our own. Their light shifted to longer wavelengths by their recession, and that the farther away they were, the faster they were receding. The universe was expanding. It had always been expanding. Einstein's reason for introducing the cosmological constant, maintaining a static universe, was wrong from the start. He wrote to colleagues calling the constant his greatest blunder, the worst mistake of his scientific career. He removed it from his equations. For the next 7 decades, it sat in the history of physics as a cautionary tale, the story of a great scientist fudging his equations to preserve a preconception and then having the intellectual honesty to admit it. In 1998, Saul Perlmutter, Brian Schmidt, and Adam Rees, working independently on 2 separate teams measuring the brightness of Type Ia supernovae at cosmological distances, discovered something nobody had predicted. The expansion of the universe was accelerating. Galaxies were flying apart, and accelerating as they did so, faster and faster, driven by something acting against gravity on the largest scales, something with negative pressure, something that filled space uniformly and grew in density. As the universe expanded, cosmologists needed a term in Einstein's equations to represent this effect. The cosmological constant, the term Einstein had added for entirely wrong reasons and then removed in embarrassment, fit perfectly. Its mathematical form matched the observations. Its properties matched what the accelerating expansion required. The term Einstein had called his greatest blunder was reinstated and given a new interpretation as the mathematical representation of dark energy, the 68% of the universe the standard model cannot explain. The force driving the cosmos apart at an accelerating rate. Einstein added the cosmological constant for the wrong reason. He removed it for the right reason. The universe then revealed a different right reason for it to exist that Einstein never anticipated and lived too early to see. The same sequence of wrong reason, embarrassed removal, and unforeseen rehabilitation may be happening right now to theoretical structures currently sitting in the discarded category of physics. Right now, in your room, there are almost certainly equations that physicists abandoned because the experiments they were designed to explain turned out to be noise, or analysis errors, or ghosts, terms crossed out in notebooks. Frameworks dismantled when supersymmetry failed, or when B-meson anomalies dissolved, or when a 5 sigma muon signal turned into an argument about which theoretical calculation to believe. Some of those abandoned structures may be pointing at something real, something the universe will eventually require a name for, and when it does, physicists will reach into the discard pile and find it waiting. The greatest blunder is not always the thing you added. Sometimes it is the thing you threw away. And right now, across thousands of preprint servers and abandoned graduate theses and conference presentations nobody remembers, there may be an equation sitting in the crossed-out margins of a discarded paper that is the closest thing to a description of 68% of everything that exists, waiting for evidence that has not yet arrived to tell us we were wrong to throw it away. In August 2025, the Atlas collaboration at CERN published a result. The language was flat, procedural, the kind of sentence that gets filed and forgotten. No significant excess above standard model background observed. 14 words, 15 years of work. The Large Hadron Collider, which required 27 kilometers of tunnel beneath the Franco-Swiss border, $10 billion of construction, and the coordinated effort of 10,000 physicists across 100 countries had searched the energy frontier and found exactly what was already known to be there: the Standard Model. Again, still, only. Understand what this means at the level of the project's original intention. The Large Hadron Collider was not built to confirm the Standard Model. It was built to break it. The Higgs boson was expected to arrive, and it did, in 2012, and that was the beginning, everyone said, of the real discoveries. Beyond the Higgs was supposed to be a landscape of new physics, particles predicted by supersymmetry, candidates for dark matter, the first experimental fingerprints of whatever structure lay beneath the Standard Model's acknowledged inadequacies. The machine was built to find cracks in the foundation. The machine ran for 15 years. The foundation held. Here is the thing about a machine that finds nothing. What it finds is precisely that. The nothing is the data. The null result is the measurement. When the most powerful accelerator in human history searches a domain of energy and returns silence, that silence is not the absence of information. It is information. And the information says this: whatever is wrong with the Standard Model, whatever is missing, whatever explains dark matter and the matter-antimatter asymmetry and the vacuum energy that should be tearing space apart, that physics does not operate at the energies the Large Hadron Collider can reach. Think about what that means. Every anomaly discussed in the preceding chapters, every place where the equations break down or refuse to close or demand a constant no theory can justify, those breaks do not reveal themselves at the highest energies human beings have ever experimentally achieved. The crack is real. The equations confirming it are real. But the physics that would explain it, the deeper layer, the actual mechanism, sits somewhere beyond the reach of the machine that was purpose-built to find it. In 2025, Atlas ran the same experiment it had been running since 2010, at the highest energies physically achievable, and returned the same result it had been returning since the Higgs. Confirmed. Complete. Matching predictions to extraordinary precision. 15 years of data, and the Standard Model has not broken, has not bent, has not shown a single crack that the machine can measure. Every physicist working at CERN knows the theory is wrong. Every physicist working at CERN knows the machine is not finding the place where it is wrong. Those two facts coexist, right now, in the same building, in the same papers, in the same minds. Here is the question the August 2025 result forces you to sit with. If the wrong answer keeps passing every test, and the right answer exists at energies the tests cannot reach, how would you ever know the difference between a science that is almost finished and a science that has arrived at a wall it cannot see past? From the inside, the data looks identical, the equations match, the predictions confirm, the machine comes back empty. And somewhere, in a territory that may be permanently beyond experimental reach, the actual structure of reality continues to operate by rules we are describing incorrectly. 15 years. The result is the silence. The silence is the shape of the problem. Stop for a moment. Set aside the data, the papers, the accelerator results. Sit with the geometry of the situation, the energy scales at which the physics beyond the Standard Model might operate, the scales where the vacuum energy problem, dark matter, and the matter-antimatter asymmetry might find their explanations. Those scales are not somewhat higher than what the Large Hadron Collider can reach. They are not twice as high, or 10 times, or even 1,000 times. The energy scale associated with quantum gravity, the Planck scale, sits at roughly 10 to the 19th power times 1 GeV. The Large Hadron Collider operates at roughly 10 to the 4th power times 1 GeV. The gap is 15 orders of magnitude. To close that gap through brute engineering, to build an accelerator that reaches Planck scale energies, would require a machine with a circumference measured not in kilometers but in astronomical units, roughly the diameter of our solar system, end to end, from our star outward past the orbit of Neptune and back again. Let that land. a ring of superconducting magnets stretching across the orbital path of the planets, an accelerator the diameter of the solar system, consuming energy at scales that presently have no engineering framework for production. The difficulty is beside the point. The project may be, in the most precise and irreversible sense of the word, impossible. For any civilization that exists within the physics it is trying to probe, there is a concept in philosophy of science called an epistemological ceiling, a level of knowledge that a system of inquiry is structurally prevented from reaching, not because of current limitations that might be overcome with time and resources, but because of fundamental constraints that cannot be engineered around. The question physicists are now taking seriously, quietly, in the language of review papers and conference asides rather than press releases, is whether the energy scales required to resolve the Standard Model's known failures represent exactly that kind of ceiling. If they do, then the crack in the foundation of physics is not a problem awaiting a solution. It is a feature of the territory. The universe was built at energy scales that may be permanently inaccessible to any observer constructed within it. The architect's tools exist at a level the building's residents cannot reach. You are, right now, living inside a structure whose blueprints are stored at an address that may have no physical path to it. Physicists have names for possible ways around this. Indirect signatures, low-energy echoes of high-energy physics, accidental windows where the scales cross. These are real, and they are being actively pursued. The point is not that the search is over. The point is what the search now looks like from the outside. A species standing at the bottom of a wall, looking up, throwing instruments at it, and watching the instruments return with measurements of the wall's surface and nothing about what lies behind it. The crack in the Standard Model was not supposed to be permanent. It was supposed to be the next frontier. The question that the geometry of the situation now forces is whether permanent is the right word, or whether permanent is only what temporary looks like when the waiting becomes longer than any individual civilization has ever survived. The deepest version of the problem is not that the Standard Model is incomplete. Everyone agrees it is incomplete. The deepest version is what happens when you try to find where it fails. Every theory that makes predictions can fail. That is, in some sense, what makes a theory rather than a faith. A prediction is a claim that can be checked, and if the check returns the wrong answer, the theory is wrong, and you know where to look. The history of physics is substantially a history of predictions failing in instructive ways. The perihelion of Mercury failed Newtonian gravity in a specific direction and by a specific amount, and that failure pointed toward general relativity. The photoelectric effect failed classical electrodynamics in a specific way, and that failure pointed toward quantum mechanics. Failures are signposts. The Standard Model has never produced a confirmed failed prediction in its domain of validity. Sit with that sentence, not with pride or satisfaction, but with the specific discomfort it should produce. Every experiment designed to test the Standard Model's predictions has returned results that match those predictions. Every precision measurement, every decay rate, every scattering cross-section, every particle mass, every coupling constant has come back within the theory's calculated range. For over 50 years, across thousands of experiments conducted by competing teams in countries with incompatible ideologies and incompatible funding priorities and incompatible institutional incentives to make each other wrong, the Standard Model has not failed once. The theory is wrong. Physicists are certain of this. The arguments were laid out in the earlier part of this discussion. The vacuum energy is off by 120 orders of magnitude. Gravity is absent. Dark matter has no candidate. The matter-antimatter asymmetry remains unexplained. These are facts about the Standard Model's incompleteness that its own architects acknowledge. The theory does not describe all of reality. It cannot. And yet, in the domain where it claims to operate, it has never been caught in an error. This is the map that gives correct directions in wrong territory. You are using it to navigate. The directions keep working. You arrive at every destination, and somewhere, the map is lying to you in a way you cannot find, in a region you may never visit. There is no comforting resolution to this. A theory that is always right and also certainly wrong is not a puzzle with a clean answer waiting in the next chapter. It is a condition of knowledge. It means the tools you have developed to find the crack are the same tools the crack does not register on. The instrument and the error are calibrated to each other. Right now, as you sit there, every experiment being run at every physics laboratory on Earth is using instruments calibrated against a theory that is known to be incomplete. The instruments keep passing their calibration tests. The theory keeps being confirmed. And somewhere in the space between what the instruments can measure and what the universe is actually doing, there is a gap that has been there since the theory was written, and that has survived every attempt to expose it. How do you find a flaw in a mirror using only the mirror? Right now, in your body, in the space where your chest meets your ribs, there are protons, trillions of them, packed into the nuclei of every cell. Each proton is made of 3 quarks. Those quarks are held together by the strong nuclear force, specifically by a mechanism called confinement, which means that quarks cannot exist in isolation. Pull a quark out of a proton, and the energy required to separate it becomes so large that it spontaneously creates a new quark-antiquark pair before the separation can complete. Confinement is, in this sense, perfect. No free quark has ever been observed. Every experiment that has ever looked for one has returned nothing. Confinement works. The strong nuclear force holds your protons together with precision that has never failed a measurement. The theory describing confinement, quantum chromodynamics, makes predictions that match experiments to extraordinary accuracy. Your body exists because confinement works. The Clay Mathematics Institute is one of the most prestigious mathematical bodies in the world. In the year 2000, it published a list of 7 problems it considered the most important unsolved problems in mathematics. For each problem, it offered a prize of $1 million to anyone who could produce a rigorous solution. One of those 7 problems is the formal mathematical proof that confinement must exist. The Yang-Mills existence and mass gap problem asks for a proof, from first principles, that the strong nuclear force in a non-abelian gauge theory necessarily produces a mass gap, which is the mathematical condition that gives rise to confinement. As of 2026, the prize has never been awarded. The proof has never been completed. The force holding your protons together, the force without which your body would be a dispersing cloud of unbound quarks and gluons, operates by rules that human mathematics has not yet proven must be the rules. The force works. We know it works because we can measure it, and every measurement confirms it. What we cannot do, what no mathematician or physicist has managed to do in the 26 years since the Clay Institute issued the challenge, is prove that the rules had to be the way they are. We cannot derive confinement. We can only observe it. This is a specific kind of epistemic vertigo. You trust a flaw not because you have been shown the engineering drawings that prove it can support your weight, but because you have stood on it and it has not fallen. The drawings do not exist. Someone built the flaw and it holds. And when you ask to see the structural proof, you are told there is none, and the flaw continues to hold, and the proof remains unwritten, and the flaw holds, and holds, and holds. What happens to the thing the flaw was holding if someone eventually proves the flaw should not work? The standard model assumes its laws are universal. That assumption is so embedded in the framework that it rarely needs to be stated. The equations are written without a coordinate system that tracks location or era, because the equations are assumed to apply everywhere, in every direction, across all of cosmic time. The same coupling constants that govern the strong nuclear force in your protons govern the strong nuclear force in a quasar 10 billion light-years away. The same rules for quantum electrodynamics that operate in this room operate in the earliest moments of the universe. The laws are everywhere, always, identical. There is no experiment that has ever tested this assumption directly, because there is no experiment that could. You can measure light arriving from distant galaxies and check whether the spectral lines match what the standard model predicts. This is done. The spectra match to impressive precision over enormous distances. What this tells you is that the physics in the narrow cone of space-time from which that light was emitted at the moment of its emission produced the same atomic transitions as the physics in your laboratory. It does not tell you anything about the vast regions of space-time you cannot observe. It tells you about the thin path of light between there and here, and nothing else. The universe we can observe is a sphere, roughly 93 billion light-years in diameter. Its edge, defined by how far light has had time to travel since the beginning. Beyond that edge is more universe. Standard cosmology predicts vastly more. Inflation models, which are required to explain the flatness and uniformity of the observable universe, generically produce a universe far larger than what we can see, possibly infinite, and in many versions produce regions with different physical constants, different coupling strengths, different mass hierarchies. If the laws of physics vary across scales, too vast for any instrument to sample, then the cosmological constant problem is not a problem at all. It is a selection effect. You are in a region where the vacuum energy takes its observed value because regions where it takes other values do not produce observers to notice. The matter-antimatter asymmetry has local solutions. The neutrino masses make sense in a different corner. What looks like an incomplete theory from inside one region is actually a complete theory of one dialect among many. Your body follows laws. Those laws work. They have worked every time they have been tested. The question the multiverse of physical laws forces you to ask, right now in your room, is whether those laws are the laws of the universe or the laws of a neighborhood. Whether the physics governing your heartbeat is a fundamental feature of reality, or whether it is a regional characteristic, a local ordinance that happens to hold within the tiny corner where your life is happening, and dissolves into something else, in directions no instrument you will ever build can point. The laws might be local. Your existence might be parochial. The universe might be operating by rules you cannot know because you are too small and too brief to see the variation. Pause here, not for drama, for the honest weight of the question. In the year 1949, a theory was completed. Quantum electrodynamics, the theory of how light and matter interact, was given its final mathematical form by Richard Feynman, Julian Schwinger, and Sein Itiro Tominaga. The theory had been assembled over the preceding decade from fragments that didn't quite fit with mathematical techniques that were, by the formal standards of the discipline, not entirely sound, involving the subtraction of infinities from infinities in a procedure called renormalization that produced finite, correct answers through a process that its inventors described as educated guessing formalized. Feynman called it a Dippy process. He meant it. When the theory was completed, its creators were not satisfied with it. They were proud of the predictions, which were extraordinarily accurate, and disturbed by the structure, which was, in their assessment, held together with conceptual tape. The working assumption among the people who built it was that quantum electrodynamics was scaffolding, a temporary framework that gave correct answers while a deeper, more principled theory was being found. Something to use while the real structure was under construction. Most of the major figures in the field expected to be replaced within a decade. Freeman Dyson, one of the architects of quantum electrodynamics, wrote in 2006 that the theory remained a jerry-built structure in the same sense it always had been, that the infinities had been removed by mathematical procedures rather than genuinely explained, and that the theory's extraordinary predictive success was in some ways a problem, precisely because it removed urgency from the project of replacing it. The scaffolding had become load-bearing. The temporary fix had been in place for 57 years when Dyson wrote that, and it has been in place for another 20 years since. 77 years total. There is a specific kind of institutional forgetting that happens to warnings issued too early. The warning gets noted, filed, acknowledged in review articles, cited as a known limitation, and then deprioritized because the structure it is warning about continues to function. The roof holds, so the warning about the roof gets moved from urgent to background. The background warning accumulates footnotes. The footnotes accumulate decades. The warning is never resolved. It is archived. The most precisely tested theory in the history of science. The theory whose predictions match experiments to 12 decimal places was described by its creators as a jerry-built structure that needed to be replaced. That description was accurate in 1949. It remains accurate now. The theory has been in use for 77 years past the point where its own architects expected it to be superseded. Ask yourself what it means to be living inside a jerry-built structure that has lasted 77 years past its predicted expiration. Ask yourself whether the fact that it has held this long is evidence that the concern was wrong, or evidence that no one has found what is actually wrong with it yet. Here is the inversion the preceding chapters have been building toward. The title of this documentary names CERN as the entity that found the crack. The claim has weight. The Large Hadron Collider is the most sophisticated experimental apparatus ever constructed. The machine that confirmed the Higgs boson, that has collected more data about the interior of protons than any previous instrument in history. If a crack in the Standard Model is going to be found anywhere, the Large Hadron Collider is the machine most qualified to find it. But CERN did not find the crack. CERN revealed that the crack had always been there. There is a difference, and it matters. Finding a crack implies it was created by, or at least made visible by the investigation. Revealing a pre-existing crack is a different kind of result. The crack was present in 1949, when Feynman and Schwinger and Tomonaga built their jerry-built structure and told each other it would need to be replaced. The crack was present in the 1970s when the Standard Model was assembled from its pieces, and the missing terms, gravity, dark matter, the vacuum energy, were recognized as missing. The crack was present in 1998 when dark energy was discovered to be accelerating the expansion of the universe, and the vacuum energy problem grew from a theoretical embarrassment to an observed physical reality. In 2012, when CERN found the Higgs boson and completed the Standard Model's particle content, the celebration was real, and the incompleteness was also real, simultaneously, in the same announcement. The last piece of an incomplete framework had been found. Everyone agreed it was incomplete. And then the Large Hadron Collider kept running, kept searching the post-Higgs energy desert, kept returning results that matched the confirmed incomplete theory and nothing else. 15 years of silence. The silence is not the crack. The silence is what the crack looks like from the outside when no instrument can get beneath it. The Large Hadron Collider's null result, the absence of every new particle that was supposed to arrive after the Higgs, is the most precise measurement of the crack's location ever made. The crack is below this floor. The crack is at a depth the machine cannot reach. The crack was there before the machine was built. The machine spent 15 years and $10 billion walking the perimeter of the hole, mapping its edges, confirming its dimensions, and returning that map to the people who built the machine to go deeper. The crack was always there. CERN just ran out of room to pretend otherwise. What does it mean that the most important result produced by the largest scientific instrument in history is a confirmation that the problem is exactly where everyone knew it was, at a depth that may be permanently unreachable? Think about the objects in your life. The device you are using right now to receive this, the network transmitting it, the medical imaging technology that, if you have ever been examined by it, produced a cross-section of your body's interior without cutting into you, the global positioning system that knows where you are to within a few feet at any moment, the solar panels being installed on rooftops across the world, converting light from our star directly into electricity, the fiber optic cables carrying the internet across the ocean floor at the speed of light, Every one of these technologies depends on quantum mechanical effect. The transistor, the foundational unit of every computer ever made, operates because of quantum tunneling and band gap physics, phenomena that are predicted by quantum mechanics and incorporated into the Standard Model framework. The laser operates through stimulated emission, a quantum effect. Magnetic resonance imaging uses the quantum spin states of hydrogen nuclei. Global positioning system satellites require corrections from general relativity to maintain the accuracy the system depends on. Corrections calculated using equations that are separate from the Standard Model and known to be structurally incompatible with it. Every engineer who built these systems was working with equations the physics community had already identified as incomplete. The word for that is simply accurate. A description of the actual situation stated without apology for the engineers or the physicists who handed them the tools. The infrastructure of the modern world, the device in your hands, the network connecting you to everything, the medical systems that have extended human lifespans, was built on a theoretical foundation that its own authors described as provisional, jerry-built, needing replacement. The replacement was never completed. The technologies were built anyway. They work. You have never stood on the real floor of physics. Every technology you have used, every system that has extended your capabilities or saved your life or connected you to other people, rests on a successful approximation, remarkably successful, irreplaceable in practice, and an approximation nonetheless. The engineers built a functional civilization on the scaffolding Feynman apologized for. The scaffolding became load-bearing, as all good scaffolding eventually does. The provisional became permanent. The temporary fix became the floor of the world, when the real floor is eventually found, and if it is, and the approximation is revealed as an approximation in some domain where the difference is measurable and consequential, which technologies will turn out to have been built on the part of the map that was wrong. The 4th of July, 2012, Geneva. CERN holds a press conference. Peter Higgs, the physicist who predicted the boson bearing his name in 1964, is in the audience. He is 82 years old. He wipes tears from his eyes when the announcement is made. The Higgs boson has been observed at a mass of 125 GeV, precisely within the range the Standard Model required. The final piece of the framework, built over the preceding 60 years, has been found. The Standard Model is, in its particle content, complete. Everyone in that room knew the Standard Model was incomplete. The Higgs boson completed the zoo of particles the theory required. It did not touch the vacuum energy problem. It did not provide a dark matter candidate. It did not explain the matter-antimatter asymmetry. It did not incorporate gravity. The completion of the Standard Model's particle content was the completion of an acknowledged fragment. Everyone celebrated, and everyone knew what they were celebrating was the last page of a chapter in a book that had not been finished. The Large Hadron Collider then ran for 13 more years. The history of physics since 2012 is the history of the most powerful experimental machine ever built, confirming, with increasing precision and increasing energy, a theory that is universally acknowledged to be wrong. Every year since 2012, the machine has searched and found nothing beyond the Standard Model. Every year, the silence has grown more informative. Every year, the energy frontier has extended and returned the same result. The silence accumulates. The baseline of what the Standard Model predicts has been checked at energies that would have been unimaginable in 1964, and it matches, and nothing new appears. Consider the shape of that silence. If there are new particles at higher energies, the Large Hadron Collider has not found them because the energies it can reach are not high enough. If there are new particles at those energies, they are not interacting in ways the detectors can resolve. If there are new particles, they have remained hidden through every search strategy, every analysis technique, every dataset collected over 13 years of operation. The silence is consistent with a very specific possibility that the physics beyond the Standard Model operates at an energy scale the machine cannot reach. and that the machine has mapped the ceiling of what is experimentally accessible to human civilization at this point in its development. 13 years of silence after the most celebrated discovery in a generation. If this silence is the shape of a wall, a permanent boundary of experimental access, then the 4th of July, 2012, may represent something more than the completion of the Standard Model. It may be the last major experimental result about fundamental physics that human beings will ever produce. Sit with that, not with despair, but with honesty. If the next layer of physics is forever beyond reach, what does that make 2012? Come back to the room you are sitting in. Come back to your body. Right now, your heart is beating because of electrochemical signals passing through cardiac muscle cells. Those signals depend on ion channels, protein structures that span cell membranes and open and close in response to voltage differences. The voltage differences are maintained by ion pumps, molecular machines that use energy from adenosine triphosphate to move sodium and potassium ions against concentration gradients. Every one of these processes is governed by quantum mechanical effects at the atomic level. Every one of those effects is described with extraordinary precision by the Standard Model of particle physics and its precursors. The Standard Model is incomplete. This has been established. The vacuum energy it predicts does not match the vacuum energy observed by a factor of 10 to the 120th power. The matter-antimatter asymmetry it cannot explain is the reason you exist, and there is no mechanism in the theory to produce the asymmetry that produced you. Dark matter, which makes up 27% of the universe's total energy content, appears in no term of the Standard Model. Gravity, the force that holds the planet you are sitting on in orbit around our star, cannot be incorporated into the theory's mathematical structure without breaking it. These are not minor issues awaiting clean resolution. They are structural absences in the only theory of matter we have. Your body is governed by incomplete equations. Your heartbeat is predicted to extraordinary accuracy by a jerry-built structure that Freeman Dyson in 2006 was still describing as jerry-built. The force holding your protons together works by rules no one has proven must work. The atoms composing your body exist because of an asymmetry between matter and antimatter that the equations cannot explain. You are made of a kind of matter that makes up less than 5% of the total energy in the observable universe. The remaining 95%, dark matter and dark energy, has never interacted with a single instrument ever built by human beings. The Standard Model will be replaced. Every physicist on Earth agrees on this. The theory is wrong. The question has never been whether it will be replaced. The question, the one that the 15 years of silence at CERN, the gap of 10 to the 11th power between the Large Hadron Collider and the energies where the answers might live, the $1 million prize still sitting unclaimed at the Clay Mathematics Institute, the 77 years of jerry-built scaffolding have been building toward, is whether we will ever know what replaces it. The crack has no bottom that any instrument yet designed can reach. The floor of physics, the actual floor, exists at energies that may require an accelerator the size of the solar system to access. The theory describing your existence is incomplete in ways that may be permanently beyond the experimental range of any civilization that exists within the physics it is trying to understand. The equations governing your heartbeat work. The proof that they must work does not exist. The reason you exist cannot be derived from the equations describing you. The map ends here, somewhere, beyond the edge of the reachable. The complete structure exists. The thing that built you, the actual rules of the universe at the level of its foundations, is operating right now, in you, around you, in the air between your body and the walls of the room. It is fully present and entirely invisible. Every instrument ever built has found only its shadow. The shadow matches the predictions. The thing casting the shadow remains, as of this moment, and possibly as of every moment that will follow, permanently out of view, The crack does not close. The map ends here, and the territory goes on.